Okay, so I'm going to talk about automating accessibility in digital authoring workflows. So specifically for creators who create content which might be consumed by all kinds of end users, including people with disabilities. And I'll be talking about two AI tools that I worked on during my master's thesis, which help with the automatic production and preservation of accessibility metadata in the workflow. And in a bit, I'll explain what this metadata is and what exactly we're producing into Silicon. So in a digital authoring workflow, there's an author who's producing some form of content, and there's a consumer who's consuming that content. And most of my work focuses on consumers which have visual impairments, so they're often using assistive devices such as assistive software such as screen readers. But there's not just the author and the consumer, there are also intermediaries in this workflow. Um, so for example, the author might be using some, so the author might be using some authoring tool, um, and that authoring tool renders the content in some form, which is then ultimately consumed by the end consumer. And I have organized this talk in three parts. So there are three legs. Each of these legs represent the handoff, the data handoff between each stakeholder. And I'll be starting from the consumer's end and making my way back to the author's end. So first I'll give a brief introduction about what is the kind of metadata that we're trying to preserve here. How do we provide it to a consumer that may have a disability? And then I introduce the two tools which focus on preserving and then producing that accessibility metadata. So providing accessibility metadata. So this work is focusing on making digital content accessible to people with disabilities. And like I said, different people with different disabilities, their disabilities can affect how they interact with the content. So for example, somebody with a visual disability might have difficulty seeing and understanding content, and they often rely on assistive technologies like screen readers, which can read out the content on the screen and narrate it for the blind user. Similarly, other kinds of disabilities affect computer use in different other ways. But in this talk, I'm going to focus on screen reader as an example of the kind of assistive technologies that the consumers use. And I'll be giving examples of the kind of metadata which is important for screen readers to provide that content. So the goal of the work is to make content accessible to these assistive technologies. So in this work, I'm focusing on making content accessible to a screen reader. So this is how we see digital content. On screen, there's an example of a research paper. And from this image, you can make some inferences about the content. So you can understand that there's a title, there are some authors and a figure in this paper. But this is how a screen reader sees this content. So I'm now going to play a video of the screen reader narrating the content on the screen. And you can see the transcript in the box down here below. Okay, so did anyone notice anything weird going on over here? Yeah, sure.
So the way we would read it is basically read an entire block at one time instead of like going line wise.
Mhm. Yeah, so we usually see some forms of visual cues in content, which helps us to organize the content when we're consuming it. And this is exactly the kind of metadata which we need to provide to the screen readers so that they can also help the consumers consume the content in that form. And examples of these visual cues might be some form of semantic grouping and labeling of different forms of content. So, for example, these labels for every form of content on the page, or the order in which we read this content. This is another form of metadata which might be required. And there's also an image over here. And just by looking at the image, we can make some inferences about this image. But in order to convey this image to a person who cannot see the image, we need to provide some form of alternate text description to the consumer. So these are some examples of metadata which might be required by a screen reader. And screen readers then provide this metadata to the consumers. But the challenge is that it needs to exist in the content in the first place. So, for example, we were just talking about PDFs. So most PDFs actually do not comply with accessibility guidelines at all, which means that most of these PDFs don't have this required metadata for the screen reader. And this is not just applicable for PDFs, but overall, we have seen this trend um, in all forms of digital content. So, for example, most websites have a significant number of accessibility errors. Um, and often people post images on social media, but they do not add alternate text descriptions. So this lack of accessibility metadata is a well documented problem in this space. And this metadata is actually very important for people with disabilities. And one might think that people with disabilities are a very small section in in the broad population, so it might not be that important to provide this metadata. But here's an example of different kinds of per country, the number of people who use the internet in that country. So you can see that deaf and hard of hearing users and blind and low vision users in the US alone have significantly more online presence than a lot of other countries that exist. So actually, they do make up a huge chunk of the population that we need to cater for. And this metadata is not only important for assistive technologies, but it also powers other important technologies, um, such as information retrieval technologies, or nowadays LLM agents for computer use also often rely on this metadata. So now that we understand what metadata we're talking about and how we can provide it to the user, we'll now talk a little bit about how we can preserve that metadata in the digital content. So there's this entire range of accessibility remediation tools which have come up, which help content creators actually preserve this metadata in their content. So here is an example of Adobe Acrobat. This is a tool which a lot of users use. We as researchers might also use Adobe Acrobat to provide different kinds of tags in a PDF. These tags are the bounding boxes that are shown on the screen, which classify what information it contains and how it is read by a screen reader. And these tools have some automation, but their automation is really poor. So if you see the Adobe Acrobat's auto tagging, it might just generate bounding boxes based on some form of like visual appearance, but not really take into account what it actually means. So for example, here Adobe Acrobat created a bounding box for each author, and didn't really tag the affiliation of the author with the author name. So when a screen reader goes through this content, it would read out all the author names and then read out all the affiliations, and the user wouldn't be able to associate the affiliation of the author with their names. So there is this automation, but it's often just visual and not really semantic. Doesn't have semantic understanding. And the interesting challenge here is that this semantic structure already exists, often exists in the authoring tool that the authors use. So, for example, authors might be using LaTeX to write these research papers, which do contain some form of semantics in the syntax. So, for example, the title there we can see in the code is displayed as a title. There is an author. These are already tagged in the code, but all of this information is lost when the PDF is rendered in a visual format. So, this is the question I addressed in one of the projects that I worked on, which is how can we recover this lost semantic metadata when the content is rendered? So to preserve this metadata, the current range of automatic accessibility remediation tools, especially for PDFs, go follow this structure where they take the PDF, the visual rendering of the PDF, they run an object detector on it to understand what kinds of objects lie on the page. And they might extract that text using an OCR or directly from the PDF to tag the content. But to preserve this metadata, in my work, I focused on the LaTeX code and I passed that code through a parser and then provided both the OCR output as well as the LaTeX code to an LLM, which helped me associate the visual rendering with the code snippet that rendered it in the first place. And using this rendering, we can then generate semantically meaningful tags. So if we already know what the structure of the code is in the visual format, we can use that to understand what tags to give to these bounding boxes, and also use that to generate a reading order. Because oftentimes in these authoring tools, the reading order is linear, and we can just use that the reading order in LaTeX to determine the reading order on the page. So to evaluate this approach, we collected 40 PDFs, which were published at the ACM CHI and ACIDS conferences. We took their PDFs from the ACM Digital Library, and then we took the source code from the from arXiv, where authors often post their LaTeX code. And we discarded all entries where the PDF rendering of the LaTeX was not matching the final rendered version uploaded on the ACM Digital Library. And for this data set, we analyzed our approach and found that our approach actually worked well on most PDFs in our data set. So it was able to identify the artifacts on page, things which should be skipped, which are repetitive on every page, and interrupt the flow of the reading order. And it was also able to distinguish between paragraphs, captions, footnotes, and so on, which might be hard for even authors to manually tag. And it was also able to understand the correct reading order. So, for example, here, instead of having a linear flow, it is able to go from a paragraph to the footnote, which is referenced in the paragraph, and go back and then continue the flow. But we also found that our tool was ultimately limited by the capabilities of the underlying off-the-shelf models. So we were using a pre-trained object detector, which would often have difficulty in understanding figures. It might sometimes break the figure into multiple subfigures and generate bounding boxes for all of them. And the OCR that we were using only had English uh, as the language. So sometimes if there was text in the PDF which was in some other language, it would not be able to identify that and tag it correctly. So in terms of numbers, when we compared all of the different accessibility criteria, we saw that our tags perform significantly better at identifying the reading order, even sometimes even better than what the authors were currently submitting manually. Um, and for all of these different elements, such as headings, tables, lists, figures, captions, we found mixed results between our approach and what authors were manually submitting. But our approach seemed to perform much better than the baseline automatic approach, which is most often used by different researchers. Okay, so now I'll move on to the third leg. So a while ago, I was discussing all of these different kinds of metadata, which we need to preserve. And I talked about addressing a few of those, which can be inferred from the code itself. So things like semantic labeling and the reading order we might be able to understand that from the LaTeX code. But what about these kinds of component-specific metadata, like image descriptions? These might not exist in the LaTeX editor, just because the authors might not necessarily add these kinds of information to the code. And things are also static, so it's also easy to identify a single linear reading order. But what about more dynamic and interactive user interfaces, such as websites? So in case of websites, most modern web frameworks actually support accessibility. So it's often if the code is written in a way that it is well structured, there are ways to render it into an accessible format. But the challenge here is that getting developers to write this form of well-structured, accessible user interface code is a significant challenge. And not only is it a significant challenge, so the role of the developer is actually important here. So we need the developer in the loop. because the developer decides what kinds of alternate text should go in the website. The developer knows the purpose of every component and element on the page, and they need to announce things that change. They ultimately choose like the sizes in different colors, and the choices that they make in their code actually influence the navigation order. And there are guidelines for making content accessible, which can help developers write better UI code. But we've still seen that getting developers to write accessible user interface code is actually a very long-standing challenge. So if we start to map it out on a timeline, there was a paper that came out in 2004, which talked about how web developers actually wanted to support web accessibility, but often face different kinds of roadblocks, such as lack of time, training, or support from their clients, and inadequate software tools. And since then, we've been conducting all this research and developing better guidelines for developers to write better code. Yet, still, even 16 years later, we see similar results. Developers still receive inadequate education about accessibility, and their cycles just did not accommodate accessibility implementations. And if you see both of these quotes, they're actually talking about pretty much the same problem, which is even if developers were um, wanting to make their websites accessible, they might not they might not receive the adequate support or time to do that. So in this work, we thought that AI coding assistants offered this new opportunity to automatically make UI code more accessible. Many developers nowadays are actually relying on AI coding assistants to write code. And so, if AI coding assistants could automatically help developers write accessible UI code, presumably more of the code that developers write would be more accessible. So, in this work, we first conducted a formative user study with 16 developers to understand the current challenges that baseline AI assistants had with respect to accessibility. So, in our need finding study, we had 16 developers who were asked to prompt an AI assistant. And they were given different web component modification tasks. They were given existing websites on which they had to make some changes. And all of these changes had implicit accessibility considerations. So we did not explicitly tell the developers to make their components accessible. Um, and then we studied a baseline AI coding assistant's response to those the prompts that the developers had and the code it generated. So here is an example of a task that the developers were given. So they were told to make this form which enabled users to subscribe to a mailing list on a website. And this is an example of one interaction that the developer had with the assistant. So the developer said something like add a gray text box on a gray patch saying enter email ID. And we see that the developer actually fails to explicitly prompt the assistant for accessibility considerations, similar to how we didn't actually prompt the developers to make their components accessible. And without this explicit prompting, the AI assistant doesn't actually consider accessibility requirements in the code that it generated. And we saw three such problems emerge throughout our user study. The second problem we saw was that the assistant would often generate placeholder code attributes and expect the developers to fill them in, but the developers would just uncritically accept those suggestions and move on. And third issue that we found was that websites often had existing accessibility errors, which the AI coding assistants would then perpetuate in their suggestions. And so while we saw this opportunity for AI coding assistants to automate the production of accessible UI code, we saw that most AI assistants in currently didn't really capitalize on that opportunity. So we saw mixed results with and without the usage of an AI coding assistant. So to overcome these challenges, we built a plugin called CodeAli, which is a GitHub Copilot extension that helps the developers improve the accessibility of their UI code. And this is the features that it has. So CodeAli automatically generates accessibility by default code suggestions. It resurfaces existing accessibility errors so that the developer can correct them, and those errors don't get perpetuated in new suggestions. And it also sends reminders to the developers to complete their code. So I have a demo here of a website, and there's this button on the website which has poor color contrast in its default state. Um, now let's say that the developer wanted to actually add some kinds of effects to this button, like add hover effects. When they prompt CodeAI to add hover effects on the button, CodeAI automatically generates accessibility by default suggestions. So it takes care that the hover effect has appropriate color contrast. Um, it also it also sends a reminder to the developer saying that they need to actually manually verify the color contrast of the button. So it sends reminders for all those steps that might require manual intervention on the developer's end. And then the other thing it might do is that it might point out that the button, even in its default state, had poor color contrast. It resurfaces that error and it provides a fix for that error. So the developer can then go one by one and accept all of these suggestions. And we'll see that the button, as the developer keeps on accepting all the suggestions, we see that the accessibility of the button improves overall. So if we see uh, after the usage of CodeAI, the developer was not only able to add a new hover effect to the button, but even even in the default state, the button has a much better color contrast. It might be difficult to see this actually on the slide because it's very nuanced, but the accessibility of the button improves a bit. The text color in the first slide, like on the first image, is grayish, and in the second slide it's white, so there's more color contrast. And CodeAI has a multi-LLM agent architecture. So there are three agents which are responsible for all of these three features. So there's a responder agent, which generates relevant suggestions based on the developer's prompt. And it takes the chat context and the code context into in its context. And it's also fed with certain accessibility best practices and guidelines for its suggestions. Then there's a correction agent, and we provide this agent with additional context information, which is the accessibility linter logs of the website. These logs are dynamically generated and they're periodically refreshed. And based on these logs, it goes through the logs to identify relevant errors in the logs, which might be related to the task that the developer is currently working on. And then there's a reminder agent, which goes through the suggestions provided by both the responder and the correction agent and identifies any steps which might require manual intervention and generates reminders for the developer to complete those steps. So we evaluated this with another user study similar to the first need finding study with 20 developers. And we saw a statistically significant improvement in the performance of the accessibility of the UI code generated by the developers over a baseline coding assistant, which is GitHub Copilot. And not only that, we saw that the developers' perspectives were actually quite balanced between both the plugins. So the developers rated CodeAI with equal or higher satisfaction and ease of use as GitHub Copilot. So not only was CodeAI silently improving the accessibility of the code that the developers were generating, it also didn't seem to have a strong effect on developers' behavior. Yeah, so this was my master's thesis. I built two tools. One was for producing accessibility metadata in websites. The other was for preserving that metadata in the rendered content. And the key takeaways of this talk are, I think all of us care about accessibility. That's why we're here. So it's important. Digital accessibility is extremely important. And in order to do so, we need to provide the required metadata and digital content. We need much better tools that can help creators support accessibility with minimal impact on their existing workflows. And through this thesis, we saw that actually recent advances in AI and ML actually makes this possible. And this thesis is a first step towards automating accessibility in these workflows. And for future work, we could work on the accuracy and granularity of the metadata that we're preserving. So I have been continuing to work on the PDF project and improving the accuracy of the tags that are generated so far, as well as going into more granular details, for example, tagging tables and headers. We need better better or I don't think they exist in the first place. So we need accessibility evaluation benchmarks for different kinds of digital content. And through the Code-AI project, we realized that silent accessibility tools might also help raise accessibility awareness in authors. So there's again an opportunity to explore their behavior longer term as authors continue to use these tools. And I would like to end this talk by using this quote, which is our tools shape us, and so we need to be careful when we're shaping our tools. Yeah, that's it. Thank you. Okay, so I am happy to take any questions.
Yeah,
Yeah.
a great talk, really cool work. I'm interested to know how you're thinking about balancing, or you mentioned granularity. And so like this navigating this tension between what's actually useful versus say something that's very granular, maybe it's included in the metadata, but might not necessarily be pertinent to understanding the content or related to the content. So what are you thinking about? And that's good.
Yeah, I think for now, I have been preserving the metadata, which is generally based on like best practices and how to tag PDFs. So if you submit to CHI or other HCI conferences, you can often find a blog on how to tag your PDF and make it accessible. So that is the level of granularity that I have explored so far. But I feel like because there's this additional context that can come from the authored code in the first place, it does provide an opportunity to provide that extra context to the user by if the user was interested in asking more questions about, like for example, tagging the author block as a single author block versus then tagging the affiliation as an affiliation and tagging an email as an email. Going into those levels of granularity, I feel like that additional context might be able to help with that. And does anyone else have questions or comments or feedback?
I'm just curious, like, so PDFs have images and we need to describe them as well. But what are the metrics behind that? Like, how do you know if an LLM or chatbot is describing it well or not? Are there any benchmarks, any metrics for that? I think that's.
Yeah, so in this work, I didn't actually focus on like generating alt texts for images. I do know that there's work where they've studied different kinds of like what constitutes as good alt text for different kinds of images. But I think that's I might be wrong, but as per my knowledge, I think it's an ongoing research area.
So like if a PDF has certain algorithms, so like how is it explained to a person with visual disabilities?
Like a code algorithm.
Yeah, maybe a pseudocode kind of thing,
Mhm.
even if it's written in English, but still, yeah.
Yeah, like especially in like machine learning, we have like subscripts and superscripts. So
Yeah.
will it just go reading everything?
Yes. So I think that like there's this like for formulas, I think the one of the ways that it can be made more accessible is by providing LaTeX code of that formula as an alternate text description. And so actually for that case specifically, this approach is really useful because we can then directly, instead of like post hoc rendering the LaTeX code, So a lot of approaches currently take the image of like a formula or something and then try to generate the LaTeX code.
Mhm.
But through this approach, you can directly pull out that LaTeX code and upload that as a main text. Do people on Zoom have any comments?
Hi Pia, wonderful talk. And then I was just like curious for your first work with the automatically tagging with all the like read order. One of the questions I have was like when we trying to add like alt text to some of the technical papers, like for instance to describe a model architecture, like sometimes like not even the like OCR, the text is important, but also the structure itself might be also very important. So I was wondering if you have any kind of like insights on how the next time might be to kind of like provide a more like to understand the architecture to provide to people with accessibility need.
So is your question on like how to write better alt text for technical figures which have like flowcharts?
Yeah, I think so. Yeah, especially on like bigger content, like such as like modeling and model architectures, like
Um,
some of the technical figures.
yeah. I actually I'm not entirely sure about that. So I know that there are examples which you can see online on different blogs, but I'm not sure on what the best practice is for like describing technical figures. What I generally do in my papers is just describe every component and like the flow of data or whatever the flow is in the alt text, but it is difficult to abstract that figure into like a textual description.
I remember, I don't recall the whole words for that, right?
No, I
Who also focused on his writing pictures.
yeah. There is a paper that recently came out by I think it was from AI2 Institute, which was on like co-authoring all texts for specifically for technical figures and flowcharts using LLMs. Um, I can I can search for that and share a link with you.
Sure. Yeah. Thanks so much.
Yeah, right, you have ideas too.
Hmm.
Right. So, that is not, so.
Okay. Yeah, this one. Yeah.
Yeah, it's just a good question. So really cool work. I use like LaTeX to write paper all the time, but I know a lot of, maybe not a lot, some folks even use like Google Docs or to write their papers. So do you envision like for those kind of folks, I guess there's, I don't know if there's any like data in similar format, but LaTeX, this is more like a future word where
Yeah.
I don't know.
Yeah, I feel like because LaTeX is like a what you see is what you mean way of writing code. It you can definitely get much more semantically relevant metadata from LaTeX, which is harder to get from visual documents like Word. But there are also things in Word itself, like for example, in Word documents, which might be useful for which might be worth preserving. So like things like reading order, for example. Um, can be retrieved from the linear way in which things can be read. That might be one thing, but yeah, that is it's definitely different between different sources. How much you can preserve.
I think one more thing to add here would be that LaTeX is both the problem and the solution here, because most PDF accessibility issues come from the fact that LaTeX allows you to place text anywhere and everywhere. with Google Doc and Word, I think that's pretty much limited. So I think these kind of accessibility issues are even lesser with like text editors.
Yeah, that's actually true. So there was a paper on benchmarking PDF accessibility, and they found that the worst PDFs were actually latex-born PDFs.
Yeah.
In terms of accessibility compliance. Okay, I guess then we can end the meeting early.
Okay, stop.